What's going on, guys? My name is Miss Birch, and welcome back. Welcome back. We're talking about math. As always, we love talking about math. So let's get started. As always, we start our lessons by reading our standards and our objectives. So let's get to it. Let me share my screen. There we are. And let's give them a read. So I got one standard for you today. That standard is order 3 objects by length. Compare the lengths of 2 objects indirectly by using a third object. Okay, so we're going to be talking a lot about measuring again today. Sounds good. So let's move on to our objectives. So as always, I'm going to say it first, then we're going to say it together, and then we'll move on to the next one. So you ready? Perfect. I can order, measure, and compare the lengths of objects. All together, I can measure, I can order, measure, and compare the lengths of objects. Nice job. So the next one we have, I can use manipulatives to measure an object. Altogether, I can use manipulatives to measure an object. So I want to come back really quick. Hello. So today we're talking a lot about measurement and the differences between measuring more than 2 objects by using a third object. So before we dive into that, of course, we're practicing our math fluency. We're going to be skip counting again today. So I'm going to share my screen. We're going to skip count 2s, 3s, and 5s, but higher than we've been doing it before. Sound like a plan? Excellent. So let's get to that, and then let's get to our lesson. Let me share my screen. All right, let me share myself. Hello. Here I am, and let's hit it. So first, we're going to skip count by 2s to 40. So last time we went to 20, now we're going to 40. You think you can do it? I know you can. Let's hit it. Ready? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Nice job. But as always, what goes up must come down. We're going in reverse. Are you ready? Starting at 40, all the way down to 2. Let's hit it. All right. 40, 38, 36, 34, 32, 30, 28, 26, 24, 22, 20, 18, 16, 14, 12, 10, 8, 6, 4, 2. Nice job. That was so much more. We went from 20 all the way up to 40 and then backwards. That's so tough. I'm so proud of you guys for keeping up. Keep practicing those 2s. But now we're moving on to the trickier ones, which is my least favorite, but we got to practice it anyways. Our 3s. We're counting by 3s, 45. So last time we went all the way to 45. So you ready? Let's hit it. All right, starting with 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 39, 42, 45. Nice job. So we started at 30 last time. Now we're all the way to 45. But of course, we're going in reverse now. Let's hit it. Starting at 45, 45, 42, 39, 36, 33, 30, 27, 24, 21, 18, 15, 9, 6, 3. Nice job. Nice job. We crushed those threes. We did even better with the twos. All right, moving on to our last one for our math fluency. Fives. We got this. And guess what? We're counting all the way to 75. So we went from 50 the first couple times. Now we're jumping from 50 to 75. Think you can do it? I know you can. All right, so let's start with 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. Nice job. You guys did it. Perfect. But once again, we got to go in reverse. All right. Starting at 75 all the way down to 5. I think we can do it. I know we can do it. 75, 70, 65, 60, 55, 50, 45, 40, 35, 30, 25, 20, 15, 10, 5. Nice job, you guys. Nice job. So that's it for our math fluency. I'm going to come back and we're going to talk about what we're doing next. All right, hello. So great job with that math fluency. Keep it up. Keep up all that good work. I know you guys are practicing. I know you guys are doing your best, and it's really showing, and I'm so proud of you guys. All right, so as always, let's start with our application problem, or my favorite, our word problems. So I'm going to share my screen, and let's hit it. All right. So as always, I'm going to read it first, and then we're going to take a minute. We're going to pause. We're going to look over what we need to know. Then we're going to read it again. All right. So here we go. Julia's lollipop is 15 centimeters long. She measured the lollipop with 9 red centimeter cubes and some blue centimeter cubes. How many blue centimeter cubes did she use? All right. Let's brainstorm. What is the important information I need to know right now? What is my equation going to look like? What is the question asking me? Okay, you ready to read it again? Let's do it. Julia's lollipop is 15 centimeters long. She measured the lollipop with 9 red centimeter cubes and some blue centimeter cubes. How many blue centimeter cubes did she use? All right, so we're going to be going over this application problem or our word problem a little differently. First off, I'd like to say, I do not have blue centimeter cubes. I have pink ones. I have red and pink ones. So that's the one we're going to be working with. So don't get confused when you don't see blue. Second, that I did this problem from a different angle. So we're going to be watching a video on how to solve it. You ready to watch? I knew it. Let's hit it.
All right, so according to our word problem, we know that Julia has a lollipop There it is. Look at that. So good. And we know that it is about 15 centimeters long. And she used 9 red centimeter cubes to measure it out first. Then she switched to pink. So how many pink ones did she use? Let's find out using the information we already have. So we're going to start with our red centimeter cubes. And she put 9 down. So to start off, we got to start at our endpoints, right? There and there. Perfect. So we're going to start right there, and we're going to start with our first red centimeter cube. There we go. So 1, 2, a little tricky, 3, 4, 5, 6, 7, 8, and 9. All right, so now we need to find out how many pink ones she used. So we know we started with 9 and the total is 15. So how can we find the rest? So let's count on. So we have 9 right here. Let's just continue the counting until we get to 15. Ready? Here we go. 10, 11, 12, 13, 14, and 15. Nice job. So as you can see, we have from endpoint to endpoint, we have 15 total. Nice. We have 9 up here, and then how many do we have in pink? Let's find out. 1, 2, 3, 4, 5, 6. Awesome job. So we had 9 plus 6 more cubes. We got 15. Nice job.
All right. Let me come back. Hello. So that's how we solved that problem. On my whiteboard. What did that kind of remind you of? So she used 9 red cubes and some pink cubes to get a total of 15 cubes. How could we have written that as an equation? Ooh, like this. 9 plus blank equals 15. We've seen this before. And we use a different strategy to solve it. What could we use? We could use the count-on strategy. So if we have 9, you need to get to 15, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6. Just like we saw in the video, right? So what if I drew it? So if we had, let's say, 9 cubes, let's pretend that these are centimeter cubes. 2, 3, 4, 5, 6, 7, 8, 9. We need to get to 15. We have 9. Let's just draw however many more. 10, 11, 12, 13, 14, 15. And let's color that in so we know that we're working with different colors. Isn't this basically what we got from that video? We did. We have 9 starting centimeter cubes. We added 6 more. We had a total of 15. Nice job, you guys. All right, so now I'm going to show you another video of what we're really going to be working with today. So let me share my screen. Here we go. All right, and here we go.
All right, so now what we're going to do is we're going to take a look at 3 different objects and compare their sizes. That sounds like so much fun. So let's see the objects. We have a glue bottle, and next we have a card, and then last we have a pencil. Perfect. So take a second and look at these and start thinking, what are the size differences? What are my measurements going to be? So if I look at the glue bottle, how does it compare to the card or to the pencil? So let's get started with measuring. I'm going to clear the board and we're going to look at the glue bottle first. All right. So let's look at the endpoints. We need them to match up with that. So I'm going to grab my centimeter cubes, just like that. We're going to line up with the first endpoint and start there. So we have 1, 2, 3, 4, 5, 6. Oop, a little trouble with that one. 7, 8, 9, 10, 11, and 12. All right, so how many total do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 cubic centimeters, or centimeter cubes, I'm sorry. So I'm gonna write it down. We got our glue bottle and we have 12 centimeter cubes. All right, so let's move on to the next one. So I'm going to clear away everything in front of us. And let's bring out the next object, which was the card. All right, so this one might seem a little smaller, but let's measure it out. Let's make sure. Check those endpoints. That's where we're starting, right? All right, so let's grab our centimeter cubes, line it up at the endpoint. We got 1, 2, 3, get a little closer, 4, 5, 6, and 7. All right, see how it matches up right at the endpoints perfectly? 1, 2, 3, 4, 5, 6, 7. So this card is 7 centimeter cubes long. All right, nice job, guys. Let's keep it up. We got one more item. So let's clear the board. Here we go. The pencil. Are you ready? Let's go. Start always with the endpoints, of course, and let's get to measuring. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nice. Now let me come back and let's talk about this a little bit more.
All right, so as I just said, let me come back. Perfect. So we saw that this was our list. We had our glue bottle, which was 12 centimeter cubes long, our card, which was 7 centimeter cubes long, and our pencil was 12 centimeter cubes as long as well. So now we gotta talk about the difference. So when we are comparing the glue to the card, what's the difference between the two? Well, one's 12 and one's 7. Okay, but how much difference is there? So what we're going to do, we're just going to turn it into a simple addition problem, just like what we did in our application problem. So we're going to start with 7 for our 7 centimeter cubes for our card, plus blank equals 12. So this is the card, and this is the glue. So how can we solve this? Why don't we just lock 7 in our brain? And let's count up. 7, 8, 9, 10, 11, 12. So 7 plus 5 equals 12. So the difference between the glue and the card is 5 centimeter cubes. So that's what I'm going to write. I'm going to say the glue is 5 centimeter cubes. Cubes longer than the card, right? Can't forget our period. There we go. Just like that. So now, what's the difference between the glue and the pencil, though? The glue is 12 centimeter cubes long, and so is the pencil. So what's the difference between the two? Well, there is none, because they're the same size. Nice job. Good save. I tried to trick you on that one, but you're too good for me. All right. So nice job working through that. We're going to be working through that in the next lesson, too. So I think right now is a perfect time to take a break. So if you are getting a little hungry, getting a little thirsty, getting a little bored, which I don't know why you would, because it's so much fun learning how to measure. Of course it is. Um, Now's your chance. Take a break. I'm gonna give you 10 seconds to decide whether you want to pause the video or if you want to keep on trucking and move on with the lesson. So here's your opportunity. All right. So if you took a break, welcome back. If not, and you're wanting to move forward, thanks for sticking around. All right. So now we're just gonna keep practicing. So all right, so now we're going to keep practicing, and I got some more word problems for you. So instead of using our manipulatives right now, we're going to just be drawing pictures to help, because I know it's a little hard if you don't have the certain materials with you or the same ones that I have. We're going to get different measurement sizes. So we're going to practice just drawing them. So let's look for our first one. Let me share my screen. All right, here we go. Let me flip that over. Let me share my face. Here we go. There I am. All right. So I'm going to read it. We'll brainstorm. We'll read it again. Here we go. Peter's toy T-Rex is 11 centimeters tall, and his toy Velociraptor is 6 centimeters tall. How much taller is the T-Rex than the Velociraptor? Okay. Let's brainstorm. What is the important information I'm getting from this right now? Do I have an equation, and what is it going to look like? How can I draw this out so I can see the difference? All right, let's do it. Peter's toy T-Rex is 11 centimeters tall, and his toy Velociraptor is 6 centimeters tall. How much taller is the T-Rex than the Velociraptor? All right, so we come back out. Hello, and here we go. So I think what I'm going to do first is I'm going to look at the centimeters. What is each height of his toy dinosaurs? So it says that his T-Rex is 11 centimeters tall. So what I'm going to do with that is I'm going to draw 11 boxes. So you can see my drum right here, right? Like they're just regular cubes. One, actually that's a little big. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is his T-Rex. I'm gonna try to draw a T-Rex. It's not gonna be very good, but ooh, this is a very tough T-Rex. I don't think I know what a T-Rex looks like. Nope, this is pretty good. You got little tiny arms, big sharp teeth. Yep, that's his T-Rex, and it's not even that long. Let me draw it a little bit longer because he's that tall. There we go. Now we'll draw his leg and his tail. All right. Yes, that is very good. I know. All right. So his T-Rex is 11 centimeters tall, but his Velociraptor is 6 centimeters tall. So I'm going to do the same thing, but I'm going to draw 6 centimeters or 6 centimeter blocks or cubes right here. I'm gonna do that over here. 1, 2, 3, 4, 5, 6. All right, so we got 6 right here. And notice what I did right here. I tried to match these up like our endpoints would, right? Because if we had it all the way up here, it might be a little bit confusing. I don't know what a velociraptor looks like. I'm gonna be honest. I'm just gonna draw. I think it has wings. So let's draw this. Oh my gosh, this is just a bat. I'm just not gonna draw anything. We're just gonna draw a blob. Whoop. That's my velociraptor. I'm so sorry. So now, what I would like to do is take one of the strategies that we used when we were doing subtraction problems. And for every box I cross off, we're going to cross off on the other side. So we need to find the difference. So there are 11 centimeters on this side and 6 on this side. So let's start crossing off. I'm going to cross off over here. There's 1 and 1. Perfect. 2 and 2. 3 and 3. 4 and 4. 5 and 5. 6 and 6. So do I have any more that I can cross over on this side? No. So I used up all this. So what do we have left over? If we took away 6 or 11, what's left? 1, 2, 3, 4, 5. So the difference between his T-Rex and his Velociraptor is that his T-Rex is 5 centimeters taller. So now I'm going to erase this and I'm going to write my statement. Here we go. I'm going to say the T-Rex is 5 centimeters taller. And here's a fun trick. Centimeters is a really long word. So how we abbreviate or make it shorter is we just use cm for centimeters. So if you ever don't want to write out the word, just put cm. So the T-Rex is 5 centimeters taller. Nice job. All right, you ready for another one? Let's do it. All right, share my screen. All righty, share myself. There. Tanya makes a cube tower that is 3 centimeters taller than Vince's tower. If Vince's tower is 9 centimeters tall, how tall is Tanya's tower? Oh boy. Okay, so this is asking something a little funky. I'm trying to figure it out. So let's brainstorm it. What is the question asking me? What is the important information I can see from this? And how can I make it so I can see it visually? Ready to read it again? Let's do it. Tanya makes a cube tower that is 3 centimeters taller than Vince's tower. If Vince's tower is 9 centimeters tall, how tall is Tanya's tower? All right, coming back. Let's do it. Here we go. So Tanya's cube tower is 3 centimeters taller than Vince's tower. Well, how tall is Vince's tower? Vince's tower is 9 centimeters tall. So that's where I think we should start. So let's draw a 9 centimeter tower. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. There we go. So this is what Vince's tower looks like. We have a 9 centimeter cube. And Tanya's is 3 centimeter cubes taller. So how can we find out how tall Tanya's tower is? Okay, so we can draw a second tower and add 3 to it, right? Let's do it. So I'm just going to put them side by side. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have them matching up at their endpoints. Now we need 3 more, right? 1, 2, 3. Getting real close to the top. So we added 3. So let's count on, right? We have 9. So look 9 in your brain. 9, 10, 11, 12. So how tall is Tanya's tower? It's 12 centimeters. Nice job. Is there a different way we could have solved this instead of drawing a whole other tower? There is. Let me show you. So let's say that we know that Vince's tower is 9. Did I have to draw that whole other tower? No. What I could have done is in a different color marker or just color it in. There's 1, 2, 3. So now what is our equation? We see we have 9 right here. So we have 9 and 3. And that turns into 9 plus 3 equals, we should know this with our math fluency, 12. Nice job. See, there's a couple different ways you can use to solve them. All right, nice job. So I got one more for you. And this time you are on your own. So I'm going to give you 3 minutes to solve the problem. I'm going to read it. We'll brainstorm. I'll read it again. You get 3 minutes, and then it's all you. Okay? Perfect. Let's go. All right. Here we go. Miguel's pencil rolled 17 centimeters, and Sonia's pencil rolled 9 centimeters. How much less did Sonia's pencil roll than Miguel's? Okay. Brainstorm. Miguel's pencil rolled 17 centimeters. So, what is important here? What is the question asking me? And how can I visualize this for me to solve it? You ready to give it a try? All right, let's read it one more time. Miguel's pencil rolled 17 centimeters. Sonia's pencil rolled 9 centimeters. How much less did Sonia's pencil roll than Miguel's? All right, so I'm going to give you 3 minutes, and we're going to come back and we'll solve it together. All right, are you ready? 3, 2, 1. All right, you're about 45 seconds in. Keep up the good work. All right, you are about halfway done. How are you looking? Keep it up. All right, you got 1 minute to go. Okay, you got 30 seconds. Keep it up. Okay, you have 10 seconds. Are you ready for the 5-second countdown? Here it comes. 5, 4, 3, 2, 1. Nice job. All right, let me come back. Hello. All right, so let's solve it. So what did you do? We have Miguel's pencil rolled 17 centimeters, and then Sonia's rolled 9 centimeters. So what was your first step? Okay, so this time I feel like this is a good idea. You found your equation. So if we have 17 centimeters and then she rolled 9 centimeters, what's the difference? Okay, so here we go. What I'm going to do is I'm going to start with 17. Is this going to be an addition or a subtraction problem? Subtraction, because we're looking for the difference, right? Nice. 17 minus 9 equals what? Okay, so let's solve it. What did you use? Okay, let's use the number bond. Just like this, and like this. So far, so good. All right, and then we draw out our picture. 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Subtracting 9, 2, 3, 4, 5, 6, 7, 8, 9. How many is left over? You have a full set of 5, so 5 plus 3 is 8. Nice job. So now what we're going to do is we're going to write our statement. So let's put Sonia's pencil rolled 8 centimeters less than Miguel's. Just like that. And if you use a different strategy of how to find your answer, that's okay too. As long as you get the same answer of 8 centimeters, nice job. So now what we can do, even if just to visualize it a little bit better, now that we know that it's 8, here's what I'm going to do. I'm going to draw a little picture. So I'm going to draw, Miguel down here and Sonia on this side. Just like this. Looks very nice. Perfect. And they threw their pencil, so he threw his pencil. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh my gosh, let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, added an extra one. So he threw it 17 centimeters. And she threw hers 9. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. Do an extra one here. So if you didn't use the first strategy to find your equation, this is the other one you could have used. So just like before, let's cross off this equal amount of squares. So we have 9. We want to get rid of 9 on this side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So let's count the rest. 1, 2, 3, 4, 5, 6, 7, 8 centimeters. So that's another strategy you could have used. So nice job. Excellent job. I'm so proud of you guys. Measuring is tough stuff, but you guys are getting it really well. So as always, I gotta ask you at least one question before I go. So, how do we accurately measure an object? What is the correct way to start measuring for an object? You got it. The endpoints. You got to start at the endpoints. If they're uneven, we got to make sure we're starting our measurement with whatever we're using to measure at our endpoints, right? Nice. Perfect. All right. So that's it for me today, guys. I had so much fun learning with you and teaching you guys, and I hope you guys had fun too. So I hope you have a great rest of your day, and I'll see you guys real soon. Bye.